not go into the basics. Okay, I'll not go into the basics because I believe that you guys must have done it properly. So I assume you already have the base of the trigonometry, and from there directly I'm going to start. Okay, with the 11th standard things which we are going to do in trigonometry. First, before going to that, let me give an important thing that the classical name of this trigonometry is circular functions, and it's very important to know this. The trigonometric functions are historically also known as circular functions. Very important. There are two types of trigonometric. So there are two types of trigonometric ratios. One which we say as the circular functions, sine theta, cos theta, tan theta, whatever you have studied in your 10th standard. These are called as circular functions. Apart from that, we also have sine hyperbolic theta, cos hyperbolic theta, tan hyperbolic theta, and so on. And these are called as hyperbolic functions. And this what you have studied are called as circular functions. What is there in our syllabus is the circular functions. Now we will try to understand why such named circular functions. Now the problem with what you have done in your 12th standard, or what you remember about your 12th standard of your 10th standard is, as per you, that the trigonometry can only be applied on the triangles. But if you just remember, or if you just go, you will understand the name of tan theta is nothing but tangent. Cot is cotangent. Name of sec theta is nothing but secant. And cosecant is nothing but cosecant. So now the names, the tangent and the secant, appears in circles. A line which touches the circle at one and only one point is called as tangent, whereas one which touches the circle at 2 points is called as the secant. So, if my trigonometry can be applied only for the triangles, why such names? Okay. Let me consider one thing over here. This is my x-axis, this is my y-axis. There is a point P, which I am denoting as x, y. Okay. Now let me draw a circle, something like this, which passes through this point. Now let me connect this. So if this is the center of the circle, the but obviously this distance is going to become a radius. Let me draw a perpendicular from here. You know that when I write x, y, so this is nothing but x and this is nothing but y. Hence I have written here as x, y. Now, if I apply trigonometry, then this is theta, so this is opposite, this is 90 degrees, so this will become hypotenuse and this will become adjacent. So my sine theta will be opposite upon hypotenuse and my cos theta will be adjacent upon hypotenuse. So from here I will get y is equals to r sine theta, and from here I will get x is equals to r cos theta. So now I can represent the same point as r cos theta, r sin theta. So now any point on this circle, any point on this circle I can represent as r cos theta 1, r sin theta 1. So this angle is theta 1. Let us say there is one more point. Now this angle is theta 2. So I can write it as r cos theta 2, r sin theta 2. So it is a circle But I am writing each and every point lying on the circle instead of x and y as r cos theta, r sin theta, which are nothing but the points on the circle. So instead of Cartesian coordinate x, comma y, I am able to write it as sin theta and cos theta. So what does it mean? It means that you cannot or you should not limit trigonometry only up till triangles first, and second, you should remember the historical name as circular functions, because these were named as circular functions only in the 19th, at the end of the 19th century, and in 20 and the 21st century we started calling it as trigonometry. When it was introduced and when it was devised, it was never named with the name trigonometry. Instead, it was known with the name as circular function. And there is a reason why. Okay, you can just take a screenshot of there is a reason why we should know that it is the circular function. Now I said something is hyperbolic function. So later on, we are going to study hyperbola, and a standard hyperbola can be drawn something like this. I can apply trigonometry here also, and I can derive some kind of similar kind of thing. Okay, and those then be denoted as, instead of theta I'll write h theta, instead of theta I'll write h theta h theta. That will mean sine hyperbolic theta, cos hyperbolic theta, tan hyperbolic theta, and so on. And okay, this hyperbolic functions are used in the GPS, global positioning system. In the global positioning system, the coordinates which are given, that coordinate, the trigonometry which is used is nothing but hyperbolic one. Okay, it is not there in our syllabus, so I'll not spend much time on it. Okay, but it is for you to understand there is a reason why we should call it as circular functions instead of only trigonometry, so that we can always make ourselves realize that okay, trigonometry can also be applied to the circles which I have shown. Hence, we have come up with the name as tan theta is nothing but tangent tan. Okay, sec theta is nothing but secant. So now, without wasting much of the time, I will directly go to the 11th and 12th trigonometric syllabus. I am assuming that you have done trigonometry properly in your 10th standard, hence I am not going into the basics. Okay, and when I am not going into the basics, I will start directly with this form. So we are going to study one rule called as ASTC rule. Now, if we don't remember, we can remember a sentence as all silver teacups. From here I have taken A, S, T and C. So I have written A, S, T, C. So if you don't remember the order A, S, T, C, then it's better you remember the statement all silver teacups. Then take initial of all the words, and now you can remember as A, S, T, C. Why? So I am coming into my Cartesian coordinate system, and in the first quadrant I write S, A, in the second quadrant I will write S, in the third quadrant I will write T, and in the fourth quadrant I will write C. Right, this is my first quadrant, this is my second quadrant, this is my third quadrant, and this is my fourth quadrant. So here A stands for all, S stands for sine, T stands for tan, and C stands for cos. Now sec is 1 upon cos, so I will write sec over here. Cosec is 1 upon sine, therefore I will write cosec over here. Tan, cot is 1 upon tan, therefore I will write cot over here. what happened, Russian? If you are entering late, I am not going to wait. Initially, I used to wait. The only thing is you are going to lose all the explanations, nothing else. So now, if you see ASTC, so I wrote A, then I wrote S, then I wrote T, then I wrote C. Okay. Now here A stands for all, S stands for sine. Okay. T stands for tan, and C stands for cos. Then what I wrote? Okay, I wrote sine, and then cosec is 1 upon sine. Hence I wrote sine and cosec together. Then tan and cot I wrote together. Why? Because cot can be written as 1 upon 10. Hence. Then I wrote cos over here, and we know sec is 1 upon cos. Okay, therefore I have written sec with cos over here. Now what does it mean over here? Here in the first quadrant, all the trigonometric ratios are positive. In second quadrant, only sine theta and cosec theta are positive. In the third quadrant, only cot theta and tan theta are positive, and in fourth quadrant, only cos theta and sec theta are positive. So this rule has been introduced to remember the signs. Okay, which trigonometric ratio is positive in which quadrant? For that we are doing this. I am assuming that you know how to create the table. Now this we are doing because suppose I want to find out the value of what is sine of 270 degree, or say sine of 300 degrees, or say sine of 700 degrees. So if I want to find out the values, then how can I find those values? Okay, for that, at the same time, to know which trigonometric ratio is positive in which quadrant, for that we use this rule which we call it as ASTC rule. Now let us learn how to apply this rule. Okay, let us learn how to apply this rule ASTC. Okay. Before this, there are two things which we do simultaneously. Okay. So first is this, and the second, you remember this like this. Whenever it is pi by 2 plus minus theta, ratio changes to co-ratio. And whenever it is pi plus minus theta, ratio remains same. So we applied these two rules simultaneously. Okay, first we'll give the sign as per this rule, and then we will use this rule to find out whatever trigonometric ratio value, whichever angle you can find out simply by using these two rules together. Okay, any degree, 1000 degree, 1500 degrees, 2000 degrees, 10,000 degrees. What will be the value of sine 10,000 degrees? That also you can find out. Any value you can find out by combining these two rules together. So when I'm saying pi by 2 plus minus theta, pi by 2 means how much? 90 degree. It is measured in the radians. Okay, I hope you guys know what is a radian. If you don't know, I'll just give a simple introduction. Radian is the measure of unit for an angle. Now, throughout you complete your education, okay, throughout you complete your education, you will always use the unit radians for the angle and not degrees. Okay, degrees you have used only up till your 10th standard. Okay, after that you are not going to use, okay, the degrees unit, you will always use the unit radian. So what is 1 radian? So if say the radius of this circle is r, and if I cover the same distance So this distance, this we call it as length of arc. So if my length of arc is equal to the value of the radius, okay, if my length of arc is equal to the value of the radius, then the angle between this initial and the final point, this angle is called as 1 radians. It is denoted by 1 raised to c. Okay, it is denoted by the angle theta raised to c, or you also write it as theta raised to r. The way you write 30 degrees, or how you write 30 degrees, 30 then raised to 0, you write. In similar fashion, you write c or you write r. Okay, so this is what is 1 radian. So my 1 radian is nothing but, okay, the angle traversed, okay, such that this length of arc is equal to the radius. Then the angle so traversed is called as 1 radian. Now you just have to remember this relation. Pi radians is equals to 180 degree. That's it. So you don't know how much is pi by 2 radians, and it's simple. Okay, divide by pi by 2 on both the sides. So you will know that pi by 2 is nothing but 90 degrees. And pi I have already written 180 degrees. Suppose you want to know how much is 30 degrees. So we know 180 degree. How I will get 30 degree if I divide by 6? So I will divide by 6 on both the sides. So I will get pi by 6 is equals to nothing but 30 degrees. So 30 degrees is nothing but equals to pi by 6 radians. Similarly, if I divide 130 by 3, 180 degree by 3, so I will have to divide by 3 on both the sides. So I will get pi by 3 radian is equals to 60 degrees. So 60 degrees is nothing but equals to pi by 3 radian. So this is how we can write radians in degrees or degrees in radians. It's very simple and very easy. Okay. So here when I have written pi by 2, okay, here when I have written pi by 2, it means 90 degrees. And here when I have written pi, it means 180 degrees. So you have to remember these two rules. First rule is ASTC and the second. Whenever it is pi by 2 plus minus theta, ratio changes to co-ratio. Now what is co-ratio? Sine. And full form of cos is nothing but cosine. So these are co-ratios. Then tan, full form of tan is tangent and full form of cot is cotangent. So these are co-ratios. Similarly, sine and cos are co-ratios. Okay, the full form of sec theta is secant and the full form of cosec is cosecant. So again, secant and cosecant, so ratio and co-ratio. So when I say that ratio changes to co-ratio, okay, when I say that the ratio changes to co-ratio, what does it mean? Sine will get converted to cos, cos will get converted to sine. Similarly, tan will get converted to cot, cot will get converted to tan. Similarly, sec will get converted into cosec, cosec will get converted into sec. This is what I mean by ratio changes to co-ratio. If it is sine, it will get converted into cos. If it is cos, it will get converted into sine. Okay, similarly, if it is tan, it will get converted into cot. If it is cot, it will get converted into tan, and so on. When I'm writing over here, ratio remains same. So whenever I do, okay, 180 pi plus minus theta. Okay, whenever I add and subtract an angle from 180 degree, the ratio remains same. Which means if it is tan, it will remain tan only. If it is cot, it will remain cot only. If it is sine, it will remain sine only. Okay, if it is cos, it will remain cos only, and so on. Okay, please take this screenshot before I rub it out and explain how to apply the rule. Take this screenshot, everyone. Okay, I hope everyone has taken the screenshot. Okay. So now let's see how to apply this rule. so that we can find out the any values. Suppose I want to find out what is the value of sine of pi by 2 plus theta. See, if your internet speed is not good, then also the board will not be clear. If the internet speed is not good, I cannot help. Neither you can help, neither I can help. If my internet speed is not good, then also the board will not be clear. If your internet speed is not good, then also the board will not be clear. Now I don't know whose speed is there because I cannot stop teaching and check which what is the speed. Okay. If the board is not clear, try to concentrate on the words what I am speaking. Okay, when I write, if I want to find out, suppose the value of sine of pi by 2 plus theta. Okay, so apply first ASTC rule and then you apply pi by 2 plus minus theta. So now when I do pi by 2 plus theta, so this is my 0 or 2 pi. This is my 90 degrees, that is nothing but pi by 2. This is my pi, which we also call it as 180 degrees. And this is my 3 pi by 2, which we also call it as 270 degree. So when I do pi by 2 plus theta, so that is pi by 2 plus theta, I will reach in second quadrant. In second quadrant, sine is positive. So the very first thing I will do is I will give you a positive sign. And then I'll apply the second rule. What does the second rule say? It says whenever it is pi by 2 plus minus theta, ratio changes to co-ratio. So if sine is the ratio, what will be the co-ratio? Cos. So it will give me the answer cos theta. So sine of pi by 2 plus theta will give me cos theta. Suppose I write sine of 3 pi by 2 plus theta. So when I do 3 pi by 2 plus theta, which means 270 degree plus something. So when I do 270 degree plus something, I will reach in the fourth quadrant. In the fourth quadrant, who is positive, cos and sec, and which I have written over here, sine. So in fourth quadrant only cos and sec are positive, all other trigonometric ratios are negative. So I'll put a negative sign over here. And then I'll go to the second rule, which says that whenever it is pi by 2 plus minus theta, ratio changes to co-ratio. So my sine will get converted into cos. So this will give me answer minus cos theta. So sine of 3 pi by 2 plus theta will give me minus cos theta. Similarly, suppose I write cos of pi by 2 plus theta. So whenever I do pi by 2 plus theta, I will go in the second quadrant. In second quadrant, sine and cosec are positive. But which is this? It is cos. But in second quadrant, only sine and cosec are positive. Hence, first I will put a negative sign over here as per this rule. And then I will go to the second rule, which says that whenever it is pi by 2 plus minus theta, ratio changes to co-ratio. So my cos will get converted into sine. So I will write here it as sine theta. So cos pi by 2 plus theta will give me minus sine theta. Similarly, if I write cos of 3 pi by 2 plus theta. So when I do 3 pi by 2 plus theta, I reach in the fourth quadrant. In fourth quadrant, cos and sec are positive and this is cos. So I'll put a positive sign over here. And then I'll go to the second rule, which says that whenever it is pi by 2 plus minus theta, ratio changes to co-ratio. So cos will get converted into sine. So this will give me plus sine theta. Okay, so cos of 3 pi by 2 plus theta is sine theta, whereas sine of 3 pi by 2 plus theta is minus cos theta. Okay, understand this thing properly. Similarly, if I write sine of pi plus theta. So if I write sine of pi plus theta, this is pi plus theta. So in 180 degree, if I add some angle, I'll but obviously reach into the third quadrant. In third quadrant, who is positive? Tan and cot. And what I've written over here, sine. So first I'll give minus sign over here as per this first rule. And then I'll go to the second rule which says that whenever it is pi plus minus theta, the ratio remains the same. So sine will remain sine only. So it will give me answer minus sine theta. Now if I write sine of pi minus theta, if I write sine of pi minus theta, okay, then when I do pi minus theta, so 180 degree minus something will lead me into the second quadrant. In second quadrant, my sine and cosec are positive. So first I'll put a positive sign over here. Then I'll go to the second rule which says that whenever it is pi plus minus theta, ratio remains the same. So it is sine, it will remain sine only, so it will give me sine theta. So sine pi plus theta is minus sine theta, whereas sine pi minus theta is plus sine theta. Suppose if I write cos of 2 pi minus theta. So this is my 2 pi. When I do 2 pi minus theta, okay, when I do 2 pi minus theta, that is 360 degree minus something, I will reach into the fourth quadrant. In fourth quadrant, my cos and sec are positive. So first I will put a positive sign. Now whenever it is pi plus minus theta, ratio remains same. So cos will remain cos only. So I will write over here cos of theta. Okay, then suppose if I write cos of pi plus theta. So when I write cos of pi plus theta, 180 degree plus something will lead me into the third quadrant. In third quadrant, my cot and tan are positive. This is what cos. So it is going to give me negative. Then whenever it is pi plus minus theta, ratio remains same. So cos will remain cos only. So I'll get answer as cos theta. So I hope you have understood how to apply this principle. Suppose if I write sec of 3 pi by 2 minus theta. So when I do 3 pi by 2 minus theta, so I will reach in the second quadrant 270 degree minus something. Okay, 270 degree minus something means I will go in the second quadrant. In second quadrant, cot and tan are positive. What I have written over here is sec. So it will be negative. Now, whenever it is pi by 2 plus minus theta, ratio changes to co-ratio. So sec will get converted into co-ratio, that is cosec. So it will give me answer as cosec of theta. Suppose if I write tan of 3 pi by 2 plus theta. If I write tan of 3 pi by 2 plus theta, this is 3 pi by 2 plus theta. So it will lead me into the fourth quadrant. In fourth quadrant, cos and sec are positive. Therefore, I will give a negative sign. Then second rule, whenever it is pi by 2 plus minus theta, ratio changes to co-ratio. So tan will get converted into cot. So this will give me answer is minus cot theta. Suppose if I am writing tan of 3 pi by 2 minus theta. So when I write tan of 3 pi by 2 minus theta, so it is 3 pi by 2. When I do minus theta, I reach into the third quadrant. In third quadrant, tan and cot both are positive. So this will give me plus. Then whenever it is pi by 2 plus minus theta, ratio changes to co-ratio. So tan will get converted into cot. So this will give me plus cot theta. Suppose if I am writing cot of pi plus theta. So when I do pi plus theta, I will reach into the third quadrant. In third quadrant, cot and tan are positive. So first we'll give the positive sign over here. Now whenever it is pi plus minus theta, ratio remains the same. So cot will remain cot only. So this will give me answer as cot theta. So cot of pi plus theta is nothing but cot theta. Okay, everyone take the screenshot. I hope you have understood this rule ASTC. I hope everyone has understood this rule. We'll do one or two numerical so that you understand how to apply this. So I'm rubbing this. Suppose I want to find out the value of sine of 495 degrees. Okay, how much is sine of 495 degrees? So this 495 can be written as sine of 360 degree plus 135 degree. Right? Yes. 360 degree plus 135. 360 can be written as 2 pi. Therefore, this will become sine of 2 pi plus 135 degree. So when I do 2 pi plus theta, okay, whenever I do 2 pi plus theta, okay, say it is theta only. Don't get confused by seeing it as 135 degree. Consider it as theta. Okay, so whenever you do 2 pi plus theta, you are going to reach into the first quadrant. In first quadrant, all the values are positive. Therefore, I'll write sine of 495 degrees equals to first positive. Now, whenever it is 2 pi plus minus theta, ratio remains same. So this will give me sine of 135 degrees. Further, I don't know the value of 135 degree. Why? Because in 10th standard, okay, because in 10th standard, I have only done values up till 90 degree. So that's it. You don't require values above 90 degree. You can always use this and find out the values in terms of 90 degrees. So that is what I'm going to do. So sine 135 degree can be written as sine of 90 degree plus 45 degree. Okay, 135. If the board is not clear, concentrate, okay, on my words. Just give me 2 minutes. Let me see if it is not working properly. See, you guys can see it is giving me a speed of more than 19 Mbps. So it is showing a speed of more than 19 Mbps, more than 19 Mbps, then it should not, okay, then my video should not be blurred, which means the internet problem is not from my side, the internet problem will be from your side. Whenever there is an internet problem from my side or your side, okay, the board will be blurred. You have to bear with it. Okay, but when you see the recorded video, we send you the recorded video, right? So when you see the recorded video, the board will not be blurred. Why? Because at my end the speed is proper, hence it will not be blurred. The video will be blurred if and only if the internet speed on my side is slow. So you don't worry, even if the board is blurred for you at this moment, when you see the recorded lecture, the board is not going to be blurred. Okay, as of now, you only pay attention on the explanation. So sine of 135 degree can be written as 90 plus 45, which means therefore sine of 495 degree can be written as sine of 90, which I can write it as pi by 2 plus 45 degree. Now, whenever it is pi by 2 plus minus theta. So when I do pi by 2 plus theta, so I reach in the second quadrant. In second quadrant, my sign is positive. So the very first thing what I'm going to do is I'm going to put a positive sign. Next, the second rule says that whenever it is, okay, pi by 2 plus minus theta ratio changes to co-ratio. So sine will get converted into cos. That will give me cos theta. So theta is how much? 45 degrees. Hence, sine of 495 degree is nothing but equals to cos of 45 degree. Hence, sine of 495 degree is nothing but cos 45 is 1 by root 2. So this is how I can find out the value of sine of 495 degrees. Okay, let me see one more. Cos of 930 degrees. I want to find out what is 930. So when I do one rotation, I'll complete 360 degrees. When I do second rotation, 360 into 2, that is 720 degrees. So I subtract 930 minus 720, it will give me 0, 1 and 2. Therefore, I can write, okay, cos of 90 degree as cos of 720 degree plus 210 degree. One rotation means 360 degree, 360 degree means 2 pi. Okay, so 720 degree means again one more rotation. One rotation is 2 pi, so two rotations is 4 pi, three rotations is 6 pi, and so on. Okay, hence this 720 degree can be written as 4 pi plus 210 degree. Okay, so in one rotation I will take 2 pi, then one more rotation, then that will become 4 pi. So when I do 4 pi plus something, I'll reach into the first quadrant. And in first quadrant, all the trigonometric ratios are positive. Therefore, I will give here positive sign over here. Okay, therefore I'll give positive sign over here. Now, whenever it is pi plus minus theta, ratio remains same. So cos will remain cos only, so it will give me cos of 210 degrees. Therefore, I can write cos 930 degree is nothing but equals to cos of 210 degree. I don't know the value of 210 degrees, so it's okay. No worries at all. So I can write it as cos of 180 degree plus 30 degree. Right? 210 can be written as 180 plus 30. 180 is nothing but pi. Therefore, this will become cos of pi plus 30 degree. Okay. So when I do pi plus 30 degree or 180 plus 30 degree, I am going to reach in which quadrant? Third quadrant. In third quadrant, who is positive? Cot and tan. Who is this? This is cos. So this will give me negative. So as per the ASTC rule, I'll get the sign is negative. Then I apply second rule. Whenever it is pi plus minus theta, ratio remains the same. So it is cos, it will remain cos only, so it will give me cos theta, so that is cos of 30 degrees. Therefore, I can write cos of 930 degree is equals to minus cos of 30 degree. So which is equals to minus cos 30 is how much? Root 3 by 2. Therefore, I get the value of cos of 930 degree is equals to minus root 3 by 2. So this is how you can find out angle, okay, values for any trigonometric ratio for any angle by using this rule, okay, ASTC and the second rule together. Please take the screenshot of this. Everyone, please take the screenshot. I hope everyone has taken the screenshot. Now I'm going to write certain formulae. This formula are the base and very important one. It is not only required for this chapter, but it is required for each and every chapter which you are going to study after this. Be it your 11th standard, 12th standard, engineering, okay, in your physics, okay, in physics, in chemistry at many places, and in all the engineering subjects, somewhere you are going to apply these formulas, okay. So this formula which I am going to write now is very important one, and all this formula should be at the tip of your tongue. Even if I wake you up at okay night from your sleep, you should be in a position to answer those, okay, remember those formulas. Such Preparation should be E there for those formulas. So let me write the formula. Very, very important. All the next chapters, okay, all the succeeding chapters depend on this formula. Okay, somehow, somewhere, the entire mathematics depends on this formula. Remember that. Okay. So these are very important. This is not only important for this chapter. So first I am writing it as half angle formula. Now some books name it as double angle formula, but I like to call it as half angle formula because this is what fits into my logic. The very first formula sine 2x, which can be written as 2 times sine x into cos x. So now if you pay attention over here, the angle which I wrote over here is 2x. But when the angle when I wrote over here is x and x. And that is why I call it as an half angle formula. Okay, half of 2x is x. One more formula we have in terms of tan, which is very important, which can be written as 2 tan of x upon 1 plus tan square x. So this is the formula for sine 2x. Next, formula for cos 2x. So cos 2x can be written as cos square x minus sin square x. You had an identity as sin square x plus cos square x. It was not minus. Okay, your cos 2x can be written as, now again if you see attention over here, it is 2x. I have written x and x over here. Here also see I have written x and x. And that is why I like to call it as an half angle formula. Now, similar to sine, this is also having in terms of tan, and the formula is 1 minus tan square x upon 1 plus tan square x. In both the cases, the denominator is the same, 1 plus tan square x. So here also you can see the angle which I wrote over here is 2x, whereas the angles which I have written here is x, which is half of 2x. Apart from cos 2x, so cos 2x can also be written as 2 cos square x minus 1. So again you can see 2x and this has become x. You can remember it in this way, or this can be written in one more form which is very important. Because in integration and derivative and in many of the derivations of your physics, you are going to use the formula which I am going to write in that manner now. This is minus when it comes over here, it will become plus 1. So this will become, my LHS side will become 1 plus cos 2x. And in RHS, what will remain is only 2 times cos square x. Okay. So again, you can see if it is 2x, it is getting converted into x. Remembering this formula in this form is also very important. At many places, not only in your 11th and 12th standard, but also in your engineering. Okay, throughout your engineering career also you are going to use this formula as 1 plus cos 2x. Okay, so the same formula can be written as this way also. You have one more formula for cos 2x. Okay, it can be written as 1 minus 2 times sine square x. So again, if you pay attention, it was 2x, it has become x. Again, it can be written as the similar fashion. If I take this term over here, this is negative, it will become positive. This is positive, it goes over there, it will become negative. So it will give me 1 minus cos theta. So I can write it as 1 minus cos 2x. This will go over there. So 2 times sine square x. Important to remember, again see here there is 2x and it is becoming x, and that is why I love to call it as half angle formula. Okay, it fits into your logic completely properly. The angle, whatever angle you write on the RHS side will become half, whatever angle you are writing on the LHS side, and when you write the formula for the RHS, you just have to make the angle half. So the same two formulas can be remembered as 1 plus cos 2x, 1 minus cos 2x. 1 plus cos 2x is 2 times cos square x, and 1 minus cos 2x is 2 times sin square x. Then tan 2x. Okay, tan 2x can be written as 2 tan of x upon 1 minus tan square x. Be very careful with this. This is similar to what we have written over here. The only change is over here in the sign. There also it is 2 tan x upon 1 plus tan square x, and here also it is 2 tan x. But here it is upon 1 minus tan square x. Again 2x, and it has become x, and that is why I love to call it as half angle formula. Apart from this, we have one more formula for sine and cos. Sin 3 theta can be written as 3 sin theta minus 4 sin cube theta, and cos 3 theta can be written as cos cube theta minus 3 cos theta. Again, the formula are similar. Okay, you can remember it as in both the formulas, along with coefficient 3, you have power 1, and with coefficient 4, you have cube term. There you have 4 sin cube theta, and here you have 4 cos cube theta. So for coefficient 4, there is a cube term, and for coefficient 3, there is a degree 1 term. Okay? This is not a half angle formula, this is another formula, another set of formula. Only these three formulae are called as half angle formula. This is not called as half angle formula. Okay, this is a different formula for sin 3 theta and cos 3 theta. Please take the screenshot of this. All these together are also called as compound angle formulae. Now I am going to write furthermore formulae. All this set of formulas are also called as compound angle formulae. Done? Okay, done. Next. Next set of formulae, these are very, very important. The first set of formula is called as sum and difference. So the name itself suggests there it is going to be sum also, and there it is going to be difference also. So sum means addition and difference means subtraction. So the formula is going to have both the things. So the first is sin of x plus minus y can be written as sin x into cos y plus minus cos x into sin y. So two different formulas I have written as a single formula. Similarly, cos of x plus minus y can be written as cos x into cos y minus plus sin x into sin y. Now be very careful over here. Okay. See, here it is plus minus. So here also it is plus minus. Here when I am writing plus minus, here I am writing. I want to write the formula for cos of x plus y. So that will be cos x into cos y minus sin x into sin y. If I want to write the formula for cos of x minus y, then I'll write cos x into cos y plus sin x into sin y. Minus over here I'll write plus. When it is plus over here I'll write the opposite sign, that is minus. One more very important thing which you should always remember, which will help you in the next formula also, is the cos formula will always have pure sine terms or pure cosine terms. Any formula. and my sine formula will always have mixed terms. Okay, my sine formula will always give me mixed terms. So even if you just remember sine 2x which we had just written, it was 2 times sine x into cos x. Now when we wrote cos 2x formula, it was okay 2 cos square x minus 1 or 1 minus 2 sine square x. So either in terms of cos or either in terms of sine. Okay, whenever we have formula for cos. Next, third formula in this category is tan of x minus y. Here also be careful. So it will be tan x plus minus tan y upon 1 minus plus tan x into tan y. So it is, if it is plus minus in numerator it will be plus minus, but in denominator the sign will become opposite. If it is plus over here, you have to write minus. If it is minus over here, then you have to write plus. Okay, so this is sum and difference method of sum and difference formula. Now before going to next, there are two sets of formulae. Sum into product and product into sum. Before going into that, I am giving something by heart that so that formulas will become easy. And that is S plus S, okay, gives me 2S into C. S minus S gives me 2C into S. C plus C gives me 2CC and C minus C is minus 2SS. By heart this, I'll explain you what it is. You have to by heart this, otherwise the next category of formula you will never be able to remember. Take a screenshot and by heart this. You have to by heart in the way I have written over there. Done by hearting. Okay, have you by hearted? Okay. So now S stands for sine and C stands for cos. As simple as that. Okay. S stands for sine and C stands for cos. See here what I wrote something purely sine or purely cos. Again you can see over here. When it is formula for cos, it will give me either purely cosine terms or either it will give me purely sine terms. Where it is formula for sine, it will give me always mixed terms. Now let us write the formula. So the first sum into product. So suppose I have this sine A plus sine B. So here S plus S is 2S into C. So I'll write 2S. S stands for sine of A plus B by 2 into cos of A minus B by 2. Second formula, if I write sine A minus sine B. So what I've written, sine S minus S is 2CS. So first I'll write cos and then I'll write sine. Whichever you write first will always have this term, A plus B by 2. And the second will always have this term, A minus B by 2. So you don't have to worry about remembering when you are, where you have to write A plus B, where you have to write A minus B. The first terms will always be A plus B and the second terms will always be A minus B. So it's easy to remember. And hence I have written SC and CS. Okay, so that we don't make mistakes over there. Next, C plus C. The third formula, cos A plus cos b. That will give me 2 times. So that is 2 times cc. So this will be also cos and this will also be cos. First term should always be written as a plus b by 2. Second term should always be written as a minus b by 2. Easy to remember. Next, fourth, cos A minus cos B. That is 2 times. C minus C is minus 2SS, so I'll write minus 2SS. So S stands for sine, so here I will write sine. Again I will write sine. First should always be written as A plus B by 2. Second should always be written as A minus B by 2. Easy to remember the formula. So this is called as sum into product. Okay, this is called as sum into product because on the RHS side we had sum and on the LHS side we are having product. Now second set of formulas is product into sum, which means on the RHS side I am going to have the product and on the LHS side I should have sum. So again same, this RHS, the same terms I will write over here, 2 times sine A into cos B. Here I write 2 times cos A into sin B, 2 times cos A into cos B, and 2 times minus 2 times sin A into sin B. So exactly this thing what I've replicated over here. 2SC, so I wrote SC, 2CS, so I wrote CS, 2CC, so I wrote 2CC, then minus 2SS, so I wrote minus 2SS. So this is my product completed. Now on the RHS side, I should have sum. On the RHS side, I should have sum. So what it says over here, 2SC is nothing but equals to S plus S. So this is going to give me sine plus sine. So this will be sine of A plus B plus sine of A minus B. Again the same thing. The first terms will always be A plus B. The second terms will always be A minus B. Okay. Then CS, if it is CS, it is S minus S is 2CS. So I have 2CS. So it should be S minus S. So I'll write sine minus sine. The first term should always be A plus B. The second term should always be A minus. Okay, then I have 2cc. Okay, so if it is 2cc, c plus c is 2cc. So if I have 2cc, then it should be c plus c. So c is nothing but cos. First term should always be a plus b and the second term should always be a minus b. Then minus 2ss. C minus c should always be, okay, minus 2ss. So if I have minus 2ss, it should be c minus c. So I'll write c minus c. C stands for cos, so I'll write cos, I'll write cos. The first term should always be a plus b. The second term should always be a minus. Easy to remember. Okay, this formulae which I have written over here are very important and students find very difficult to remember this formula. Okay, very difficult they find out to remember this formula. Hence, I have given you this thing. You will not find these things easily in your books also. So remember this only 4 things. So if you remember these 4 things, these 8 formulae are done. Okay, this 4 formulae, these 8 formulae are done. Okay, you just have to remember, and it's easy to remember also. S plus S 2SC, S minus S 2CS, C plus C 2CC, C minus C minus 2SS. So take the screenshot. Everyone, take the screenshot. I hope everyone is taking this screenshot and I hope everyone has understood how to use these shortcuts to remember this formula. Okay, this formula, remembering this formula is very important. Okay. Do you have proper idea about degrees and radians, or you want me to explain a little bit on degrees and radians? If you have idea, then I'll move ahead. If you don't have more idea, then I'll first clear the things of degrees and radians and then I'll move ahead. Because throughout your education, till you complete your education, be it okay, graduation or post graduation or PhD, till you complete your education, we are always going to use radians and not degrees. So if you have clarity on degrees and radians, I'll move ahead. Please reply me in the chat box. Do you want me to do degrees and radians or shall I move ahead? Okay. So I'll explain you degrees and radians first. And then we'll move ahead. So how do we define degree is, I take a circle and I divide this circle in 360 equal parts. So when I divide this given circle in 360 equal parts, then each part is called as 1 degree. Then I take 1 degree and I divide this 1 degree further in 60 parts. Then each part is called as 1 minute. Okay, denoted by 1 dash. Now further, I can take 1 minute and I divide this 1 minute in further 60 equal parts. Then each equal part is called as 1 second. So now you see, I'm talking about the angles, but I'm using the units, minutes and seconds, which we use for time also. Now this is what is the problem. This is what creates the confusion, because of which we stop using the degree and we start using the radian system. If you remember in your 10th standard, in your science, you had that the sun, advanced sunrise and delayed sunset. If you remember 2 minutes, the sunrise is advanced by 2 minutes and delayed by 2 minutes. So have you ever wondered why 2 minutes only? Why not 1 5 minute and other 2 minutes? And why 2 minutes only? So I'll not go into much science about that, but if you just remember, if here there is an observer, this is an horizon. If the sun is below the horizon, it is called as sunset, and if sun is above the horizon, it is called as the sunrise. So when the rays reach to us, it reaches something like this, because there is throughout when it comes to the journey, the density is 0, and till Earth surface the density is 1.33. It will directly not become 1.33 when it comes from the space. Slowly and slowly the density goes on increasing, because of which multiple refractions are there. So path is shown curved, and then when I draw a tangent, it goes something like this. So this is the actual position, this is the apparent position, and the angle between the actual and apparent position is of 2 minutes. This is angle and not time. the angle between the actual position and the apparent position is of 2 minutes. 2 minutes is not time over here, 2 minutes is the angle over here. And since there is a difference of angle of 2 minutes between the actual and the apparent position, we say that the sunrise is advanced by 2 minutes or the sunset is delayed by 2 minutes. Now, this is what starts creating confusion, right? Sir, we thought it is time, but you are saying it is angle. And yes, it is angle. It is not time. Hence, we discarded this system, okay, which creates confusion and problem. Not only that, it is inconsistent also. How? Let us try to understand. Let us try to understand. Now, if I say it is 10 degree, then you will say it is very small angle, sir. The length of arc is also very small. Suppose if I keep on increasing the hand, what now? If I keep on increasing, the length of arc subtended goes on increasing. So this is the problem. The angle is same small. The angle is very small, 10 degree. But now when I'm increasing the arms of the angle, the length of arc subtended goes on increasing. Now this length of arc, when I talk about the earth, this length of the arm will be radius, which is nothing but 6,400 kilometers. Now we just imagine this is a small board, which is not even kilometers, which is not even half a kilometer, or it is not even 0.kilometer. So the length of arc covered is such a big. If this length increases to what is the radius of the earth, that is 64,000 kilometers, sorry, 6,400 kilometers, then what will be this length of the arc? So this 10 degree now becomes very, very big, because in that 10 degree, the length of arc is very big. So many countries will come in the 10 degree, that length of arc, because we live on the circumference of the earth. We are not living inside the earth. We are not living in the earth. We are living on the earth. Okay, we are on the earth, on the circumference of the earth. So even 1 degree is a very big distance. Okay, if you just check the GPS coordinates of Kudal and GPS coordinates of Nagarcoil, you will realize that there will be hardly a difference of 1 degree, but that the difference of 1 degree has changed my position. Okay, and the difference from Kudal to Nagarcoil is somewhere 1,000 kilometers. Just understand. So now 1 degree has become a very big unit. Hence, there was a need to divide 1 degree into 60 equal parts and further each equal part into 60 equal parts. And moreover, if I change the length of this arm, the length of the arc also changes. Hence, this is an inconvenient system. Hence, we discarded this system. So, discarding this system was only option, and coming up with the new system was requirement. Because first, it causes the confusion between time and angle. Second, it is an inconvenient system because it is changing if I am changing the length of arc. Hence, we came up with this, which I call it as a radian. This is the center of the circle, this is the radius of the circle. Now, if I take the same distance and mark over here, so this is my initial position and this is my final position. So now I rotate this by this much amount so that I'll go to my final position. So between the initial and final position, there will be an angle. Now this angle will be called as 1 radian if this length of arc is equal to the radius of the circle. So now Whatever bigger value you take, this will always remain 1 radian. Why? Because I'm saying length of arc is equal to radius. So even if the radius is 6,400 kilometers, or the radius is 12,000 kilometers, or the radius is 1 centimeter, or the radius is 5 centimeters, it doesn't matter because the length of arc is also going to be that much only. So the value of 1 radian is not going to change. Okay, hence it is a more convenient system. So this angle traversed, okay, such that my length of arc is equal to radius, then the angle traversed will be called as 1 radian. So when the angle is called as 1 radian, when the length of arc is equal to the radius of the circle, then the angle between the initial and the final position is called as 1 radian. So now suppose I want to convert degree to radians or radians to degree, how should I do? So I said you just remember this simple formula, pi radians is equals to 180 degrees. So now I can write it as pi radian is equals to, okay, 1 degree into 180. So 1 degree into 180 is 180 degree only, right? Now I can bring this term over here. So I'll get pi by 180 is equals to 1 degree. So 1 degree is equals to pi by 180 radian. Okay. 1 degree is equals to pi by 180 radians. So if I want to find out how much is 30 degree, you can write 30 degree as 1 degree into 30. Okay. So when you write 1 degree into 30, so 1 degree is nothing but pi by 180. So pi by 180 into 30. So this gets cancelled. 3 ones are 3 6, so it gives me pi by 6, which I had given you in much simpler way. So this is how I can get 30 degree is equals to pi by 6 radians, which means this is for conversion. So if I want to convert degrees into radians, I will use this formula. Okay, it's easy to remember. Similarly, same thing I can do over here. I can write over here as pi into 1 radian is equals to 180 degrees. Pi radian can also be written as pi into 1 radian, right? So this pi goes over here. So I can write 1 radian is equals to 180 degrees divided by pi. So this is the reverse one, radians to degrees. So if the values are given in radians and if you want to convert it into degree, okay, then you can use this formula. Suppose you want to find out how much is pi by 4 radians. So this you can write it as 1 radian into pi by 4. So pi by 4 into 1 radian. 1 radian can be written as 180 by pi. So I'll write it as 180 by pi. So pi gets cancelled. 180 divided by 4, that is going to give me 45 degrees. So this is how you can use that formula and convert radians into degrees. So you use this formula and convert radians into degrees, and you use this formula and you can convert degrees into radians. So now any value for degree and radian, okay, can be, okay, converted using this formula. I hope you have understood how to use this formula. Okay, so please take the screenshot of this, and I hope you have understood degrees to radians and radians to degrees. Hope everyone has taken the screenshot. Okay, let's move ahead. So now we are going to see one more system which we call it as a polar system. Till date, you have only seen one system which we call it as Cartesian coordinate system. So if I want to locate a point on the plane, what you do is you draw an x-axis, you draw an y-axis, and you represent. Suppose there is a point. I want to know the position of this point. So what I do? I draw an x-axis, I draw an y-axis. Then I say walk x steps, okay, on the x-axis, and from here walk y steps on the y-axis. So you will reach this point. Walk 8x steps on x-axis and y steps on y-axis. So if I walk x and then I walk y, then I'll reach this point. Hence the location location of any point in the Cartesian plane can be given as x comma y. This is called as Cartesian coordinate system. But apart from that, I can do one more thing. Okay, what I can do is I can take a fixed length and I can say traverse this much angle. I can take a distance r and I can say that okay, I'm over here and I can say that rotate by so and so angle so that you will reach up to point P. If I'm rotating little bit, I'm reaching over here. If I'm rotating more, I'm reaching over here. If I'm decreasing my rotation, am I not reaching to point P? So, the same thing can also be given in the terms of r comma theta. This much should be my distance r and this much should be the rotation. This much angle should be the rotation. Again, I can reach to the same point. So this, if I'm writing in the terms of r and theta, it is called as polar coordinates. And the system can now be called as polar system. So if I am writing in terms of x and y, it is called as Cartesian system. And if I am writing everything in terms of r and theta, then it will be called as polar system. So now let's derive a relation. So the way we did radians to degrees, degrees to radians, in the similar fashion, we should be in a position to go from Cartesian to polar and polar to Cartesian. So now if I apply trigonometry, it's easy. I can write sine of theta is equals to opposite upon hypotenuse. And similarly here I can write cos of theta is equals to adjacent upon hypotenuse. Hence this r goes over here, I can write x is equals to r cos theta. R goes over here, I can write y is equals to r sin theta. So instead of x, I can write r cos theta. Instead of y, I can write r sin theta. But here I want to write the value in terms of r and theta. So how can I write in terms of r and theta? Okay. So if I want like this, I can write x square plus y square. So x square will be r square cos square theta and y square will be r square sin square theta. So I'll get x square plus y square is equals to r square is common. So what will remain inside is cos square theta plus sin square theta. So we know the identity as per our 10th standard, cos square theta plus sin square theta is equals to 1. So 1 into r square will be r square is equals to x square plus y square. So from here I can say r is equals to under root of x square plus y square. So now if I need r over here, I'll substitute the value of x and y in this formula, I'll get the value of r. Now next what I need is theta. So we know x and y are cos theta sin theta. So my tan theta, if I divide y upon x, so my y is r sin theta and my x is r cos theta. So r gets cancelled, sin theta by cos theta is tan theta. So from here I'll get tan of theta is equals to y upon x. So when I substitute the value of y and x in this, I'll get the value of theta. So this is for conversion into polar. And this is for the conversion into Cartesian system. Okay. Suppose I am saying my x comma y is 3 comma 3. There is the point 3 comma 3. I want to convert it into the polar system. How I will do? I'll substitute in this formula r is equals to under root of x square plus y square. So that will be under root of 3 square plus 3 square. So that will be 9 plus 9. So my r will be under root of 18, which can be written as 9 into 2, which can be written as 3 into root 2. And tan of theta. So tan of theta is equal to y by x. My y is also 3, x is also 3, that is 1. So tan of theta is equal to tan of 45 degree, that is pi by 4, is 1. So tan gets cancelled, so I get theta is equal to pi by 4. So now r comma theta is equals to 3 root 2 comma pi by 4, that is 45 degree. So the one which I had in the Cartesian form, so the point which in the Cartesian plane was 3 comma 3. If I want to write in the polar system, so I used this formula and converted into polar system. I got the value of r and theta as 3 root 3 comma pi by 4. Suppose I have been given with r comma theta is equals to 1 comma 30 degree. So now this time I have in the polar system. I want to convert it into the Cartesian system. What I'll do? I'll use this formula. X is equals to r cos theta. So x is equals to r cos theta. So 1 into cos of 30 degree. So that will give me root 3 by 2. Y is equals to r sin theta. So r is 1. 1 into sine of 30 degree. So sine of 30 degree is 1 by 2. So this implies my x comma y will be root 3 by 2 comma 1 by 2. So I have converted this polar into Cartesian. Okay. So Cartesian can be converted to polar or polar can be converted into Cartesian. So we have two coordinate systems. One is called as Cartesian coordinate system, the other is called as polar coordinate system. And the relation between them is this. Okay, please take the screenshot. Please take this screenshot and by heart all the formulae in the next lecture when they start. Okay, I directly start with the numericals and we have to directly apply those formulas which we have by hearted. Okay. Okay, I hope everyone has understood. So have a nice day ahead. What you want in a note? What do you want me to explain in a note? You wrote something, it would be nice if you explain in a note. What do you want me to explain in a note? Which topic, which thing you want to get explained in the note? Cephas, you have written something as it would be clear if you explain in a note. So what do you mean by that? Okay. We'll see in the next lecture. Have a nice day ahead.